On a summer day some 65 million years ago, a huge asteroid struck the Earth. 70% of all living things perished. When it hit, the asteroid blasted a 130-mile-wide crater in the Yucatan Peninsula of Mexico. But that collision wasn't the first. Large strikes that cause extinctions seem to happen every 30 million years, and the hits seem to have a rhythm of 26 to 32 million years. Comet and asteroid strikes that kill from 10 to 50% of living things have happened as well. These include the 35-million-year-old 40-kilometer-wide crater that is located below Chesapeake Bay in Virginia. Encounters with comets or asteroids that are not extinction-level events happen every 10,000 years. The smallest collisions, such as the 1908 asteroid that flattened 40 square miles in Siberia, happen every 100 years. The Tunguska event was nearly 109 years ago. So let's take a look at this raw footage from the 1921 Tunguska expedition, which displayed the aftermath of the huge Tunguska explosion of 1908.
The Tunguska event occurred at around 7 a.m. local time on the 30th of June 1908 near the Podkaimenaya Tunguska River in Siberia. Witnesses saw a bluish light nearly as bright as the sun moving across the sky. What followed was an estimated 15 megaton explosion which knocked over about 80 million trees in about a 1,300 square mile area, forming a butterfly-shaped pattern. This also sent a shockwave throughout parts of Europe and Asia, registering as far away as England, about 4,000 miles away. Another interesting side effect of this blast was that for several days after, throughout most of Asia and Europe, the night sky glowed. It was so bright that people as far away as China reportedly were able to read in the middle of the night by nothing more than the glow of the sky. For a first-hand account, here is the testimony of one S. Semenov, who was about 40 miles from ground zero. At breakfast time, I was sitting by the house at Vanavara trading post, 65 kilometers from the epicenter, facing north. I suddenly saw that directly to the north, over Onkul's Tunguska Road, the sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger and the entire northern side was covered with fire. At that moment, I became so hot I couldn't bear it, as if my shirt was on fire. From the northern side, where the fire was, came strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut closed, and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that, such noise came as if rocks were falling or cannons were firing. The earth shook, and when I was on the ground, I pressed my head down, fearing rocks would smash it. When the sky opened up, hot wind raced between the houses, like from cannons, which left traces in the ground like pathways, and it damaged some crops. Later we saw that many windows were shattered, and in the barn, a part of the iron lock snapped. So what caused this massive blast? For a long time, it wasn't precisely known. When the event first happened, it drew little interest, largely because it happened in a very remote part of the world. It wasn't until some 19 years later that Leonid Kulik, a Russian mineralogist, decided to go investigate, figuring that a massive meteorite must have hit the Earth. Kulik and his team had little trouble locating ground zero of the blast, despite it being 19 years later, due to the fact that the trees acted as markers, pointing directly away from the blast's epicenter. However, once they got to the epicenter, they found a curious thing. There was no crater, as they had expected, and the trees were still standing in about a 3-mile radius at the center, but with their limbs, bark, leaves, etc., all completely stripped. So essentially, all these trees were just giant poles in the ground, with all the other trees for miles and miles around, blasted to the ground. Today's scientists are reasonably certain that it was a comet rather than an asteroid or other naturally occurring event. The comet must have been around 30 to 40 meters across, around 120 feet, and must have been traveling around 30 to 40,000 miles per hour, which is about 55 to 65,000 kilometers an hour. As it traveled through the atmosphere, the air around it heated up to as much as 50,000 degrees Fahrenheit, which is about 28,000 degrees Celsius, causing the comet to look like a giant fireball streaking through the sky. Eventually, this also caused the comet to annihilate itself around 5 miles, 8 kilometers above the Earth's surface in a fiery blast that consumes the...
Comets and asteroids are all around us. Some orbit near the Kuiper Belt, while some orbit near Jupiter and the Sun, such as Shoemaker-Levy 9, which broke into 9 parts in 1992 and hit Jupiter in July of 1994, shown in this short video clip. The Kuiper Belt orbits around our Sun. It contains ice dwarfs, microplanets, asteroids, and comets. The majority of comets, over 1 billion, orbit further out in the Oort comet belt. Something out there has been pushing comets at us every 30 million years. Several theories about the possible culprit, put out in the 1980s and the 1990s, have not yet been proved. Here are 3. Nemesis, a companion star that orbits close to our Sun every 30 million years and knocks comets out of the Oort comet belt. Half of the shifted comets leave our solar system and half travel toward our Sun and Earth. NASA says that Nemesis hasn't been found, which leads one to conclude that there are other stars capable of sending objects hurtling towards Earth, and yet none of which are known to be near enough to cause changes in the Oort object's path. Planet X, a large planet in the Oort comet belt or even on the outskirts of our solar system. As it orbits, it affects the orbits of the smaller bodies, sending some our way. Planet X is supposed to be much larger than Earth, but NASA says it has not been found. I will talk more on this in a moment. And galactic rotation. Our Sun travels around our galaxy, and as we rotate around it, our path moves up and down, much like riding waves on the oceans. At some point, our Sun nears other stars or thick gas fields, which change the movement of the comets. In 2015, a hidden planet was discovered in the Kuiper Belt, and it may be responsible for periodic comet strikes. This planet, dubbed Planet 9, is larger and closer than Planet X was thought to be, but it is probable that it could push comets close to Earth. Planet 9 could be 10 times the mass of Earth, but we can't see it. It's still a considerable distance out and too dim to be seen with our current telescopes. So how do we know it's there? It can be determined mathematically. In a January 2016 Astronomical Journal article, Caltech astronomers Konstantin Bidogen and Michael Brown wrote that 11 dwarf planets and large asteroids in the Kuiper Belt, including Sedna, which is 995 kilometers in size, have orbits that cluster together. Their orbits all close together in the same area, less than 30 degrees apart, without the objects hitting each other. This couldn't have happened by chance. The probability is only 7/100%. The clustering couldn't happen unless there was a large planet forcing the orbits of these 11 large bodies together. The hidden planet may have an orbit that passes through the orbits of the affected bodies. It could be some time before our telescopes are big enough and the hidden planet is close enough for us to see it. But these are mathematical calculations, so we have no way of knowing for a certainty when that day will finally arrive. This unseen planet is big enough to cluster 11 large bodies. But is it responsible for the periodic strikes of comets and asteroids? Only more research will tell us. So we'll keep looking up to the sky in our search for answers. As we continue searching the skies for the true position of the elusive Planet X, it is now being reported that within days of the launch of a project by ANU for volunteers to identify candidates for the ninth planet, 4 possibilities have now been found. The response from skywatchers was swift and impressive. Within days, 60,000 people had classified more than 4 million objects. If the so-called Planet 9 is as large as Neptune, shown here, and less than 350 astronomical units from the Earth to the Sun, then it's probably one of the 4 possible candidates detected in the last few days, according to scientific analysis of the announced candidates. But like most of the reports originating from agencies affiliated with NASA, one must look at the new information with a bit of skepticism and question what this really means and what this is really all about. If you get time to view our Facebook page, you will notice that we receive a number of extraordinary images and videos on a daily basis from followers across the world. There is one video taken by Louisiana resident Danny Garceau on April the 1st The video has garnered a great deal of attention. I would say that this is one of the most convincing captures of the star system that I have analyzed over the years. The brown dwarf in a very rare appearance as it orbits our sun in retrograde fashion. And there was also a series of images taken on March 16th and 17th, which are equally incredible, showing the presence of a celestial body. These images are posted on our Facebook page and can be viewed close up. First week of April 2017. On a summer day some 65 million years ago, a huge asteroid struck the Earth. 70% of all living things perished. When it hit, the asteroid blasted a 130-mile wide crater in the Yucatan Peninsula of Mexico. But that collision wasn't the first. Large strikes that cause extinctions seem to happen every 30 million years, and the hits seem to have a rhythm of 26 to 32 million years. Comet and asteroid strikes that kill from 10 to 50% of living things have happened as well. These include the 35-million-year-old 40-kilometer-wide crater that is located below Chesapeake Bay in Virginia. Encounters with comets or asteroids that are not extinction-level events happen every 10,000 years. The smallest collisions, such as the 1908 asteroid that flattened 40 square miles in Siberia, happen every 100 years. The Tunguska event was nearly 109 years ago. So let's take a look at this raw footage from the 1921 Tunguska expedition, which displayed the aftermath of the huge Tunguska explosion of 1908.
The Tunguska event occurred at around 7 a.m. local time on the 30th of June 1908 near the Podkaimanaia Tunguska River in Siberia. Witnesses saw a bluish light nearly as bright as the sun moving across the sky.